All right, appreciate it. My name is Chris Wade. I'm the CTO with Itential. Come on out here.
How's it going, everybody? My name is Kaon. I'm with the New York Times and Network Engineer.
Awesome. So we did combine these talks. So I'm going to do a little bit of kind of intro market, and Kaon's going to talk about his very specific implementation, which is quite awesome. So just a bit of the agenda. So we're going to walk through kind of what is platform engineering, how we see this. Kaon's going to talk about some of the challenges. We're going to get into some of, this is really focused about on-premises platform engineering. It was spoken about earlier that we really learn from infrastructure as code. We really adopt from software engineering, but I think more than anything, we adopt from the cloud operating model. So as we think about platform engineering, we have a lot to learn from kind of our peer group and how we can adopt it for ourselves. A little bit about the journey, and then ultimately taking on a product mindset. So with that, I think what underpins a lot of these platform engineering concepts is really moving from a human-centric way of operating to more of a machine-centric way of operating. I think a lot of this has been touched on today. We've talked about CLIs to APIs. We've talked about data's everywhere to single sources of truth. But for the purpose of this, we're going to talk a little bit about DevOps. There's a lot of discussion about this today. And as people think about DevOps, it's typically thought of in this vertical silo, right? So I have app-specific DevOps, I have infrastructure-specific DevOps, and the idea is that we combine these things together. So what happens is we combine it together, and then everybody kind of looks at it and says, well, now I have 3, 4, 100 different teams, and we see this primarily in the cloud, where we're reusing the same patterns over and over, but each team is doing them independently, right? So we're always challenged with, do we do this horizontally, or do we do this vertically? Do we combine dev and ops, or do we combine dev and ops? And I think this is the challenge for us as we think about this. But if we think about, oh yeah, we got some on the slide. It's supposed to be up and down here. So the top one is really about DevOps is going to remain dominant in application teams, right? If you go talk to your application end users, the same users that are developing the code are deploying this code. But when we think about infrastructure teams, and I think the room's dominated by these patterns here, is I don't necessarily want all my application teams consuming my infrastructure in dynamically different ways. It's challenging for me as we think about how do I have standard patterns and how I offer services. So when we think about platform engineering, a lot of people will see this more as kind of an SRE type of attitude towards the application team staying with a pure DevOps mindset. The question is, now we have these intersection points, right? And the question is, how do I engage my line of business application teams that are primarily looking at DevOps, and I'm providing infrastructure as an API? So with that, I'll turn it over to Kaon for a minute.
All right. Yeah. So I will get into my team and what we do at the Times. So the network team primary mission is connectivity. That includes the campus wired and wireless network, firewalls and all their rules, our global offices, 30 plus around the globe, bureaus and sites, the print plant out in Queens, which makes sure that the paper gets out every night, our primary data center and our backup data center, which hosts some critical newsroom apps and customer apps, our VPN solution, so people can connect back to HQ, and as well as our dev teams have workloads in multiple clouds, so we are responsible for the routing between clouds and on-prem. So there's a lot of services there, and we're a fairly small-ish team, so we had to use automation practices to make our job easier. All right. Now, when we talk about platform engineering principles, generally referring to using source control, automation, and infrastructure as code to deliver a product, as well as providing some self-service capabilities to other teams, and continually growing your product, right? So with years ago at the Times, the infrastructure team and the dev teams were a lot more closely aligned, but as cloud adoption became larger and more workloads moved to the cloud, the dev teams kind of diverged paths, right? So they started adopting a lot more tools, a lot more automation and platform engineering principles, and the infrastructure team kind of stagnated for a little bit, right? And over the last few years, we've been working on projects to shrink this gap. Now, why did that divergence happen? It's not because infrastructure engineers, don't want to learn something new, or network engineers don't want to learn something new, there's significant challenges versus a cloud environment, which is very homogeneous and consistent, has programmable constructs, versus on-prem environments. So what are some challenges that I've seen, at building automation structures in a brownfield environment? The layer 0 problem, so I mentioned all those bureaus and sites all over the world. Well, not everyone is going to be the same. There's going to be circuit availability problems or regional regulations. It's going to be a different environment everywhere. Before we even get into the network layer, layer 0 might have some issues that you have to solve first. There's going to be obfuscated work, so institutional knowledge. You might have a network engineer who's been there 10, 20, 30 years. Only one person knows how to do some specific thing. How are you going to build an automation workflow around that, right? So you need visibility there. So now, and then vendor sprawl is another big problem. In our case, we don't choose one vendor for all our products. Best firewall vendor might not be the best campus switch provider, might not make the best Wi-Fi, APs. So the more vendors you have, more models are introduced into your network. The problem, trying to automate, trying to fix one problem could have, you might have to do that multiple times for multiple vendors. Running a complex network also causes fear of the unknown, right? So you don't want to just commit and pray, or you don't want to potentially automate yourself into a fail at scale situation. So fear is always a problem, and entropy. So unexpected state changes will always happen, especially in on-prem networks. Something will change, whether in your control or out of your control, that you have to account for in your tooling. I think you
can keep it for a minute. So. As we get into talking about solutions, so I think we've hopefully laid out the challenge here. We're talking about adopting cloud operating models, and we're talking about platform engineering, which is typically towards the aggressive side of the scale. As a group and as a community, I think it's very helpful for us to think about maturity models and understanding kind of the journey. I think the folks in this room understand it fully. As you get outside of this room, people really ask, where do I get started? What do I do first? I'm sure you talk to a lot of your colleagues about these things. So we generally reference this model as we talk about getting from task-based automation up to self-serve and platform engineering. So I just put that up as a reference. Kind of challenged ourselves as a group to work on how we can evolve this. So I think one of the takeaways from this as we get into the middle of this and we get into the solution set is that we have forever been driven by externalities of our priorities, right? So people show up at our doorstep, people email us, Slack us, open up tickets, and they're requesting network services. And the question is, as we talk about how our users are used to consuming cloud services, they're used to taking those services as they want them, right? So without us defining the products that they want, they will come ask for what they want. I usually joke around this as like we have a set of ingredients for our users, but we don't have the menu. So since we don't offer the menu, they see the ingredients, they are ordering the ingredients and the combinations that they want. So the question really is, without getting into kind of all the detail here, is can we really reverse this flow? Can we start thinking about offering our customers products? This takes us, we have to go talk to them about this, but can we start offering them products so that they can start self-serving, so we can think about offering those products? I mean, it struck me earlier when we were talking about AVD with Carl, is they are packaging up the best practices for consuming Arista technology, and now I can go self-serve on that. I don't have to go do all the knobs myself. We usually give our equipment providers a pretty hard time on this, but we're starting to see little pockets of innovation from equipment providers, providing us products that we actually want to consume, versus the traditional EMSs and tools which we were kind of had to use. So I think if we think of this one level higher, the question is, how can we go from consuming tickets and executing against ingredients and start building products and menu items that our customers want to consume? And I think as Kaon gets into it, it's very interesting, how do we engage with them? I think this is a great example, but do we offer APIs? Do we put it in ServiceNow? Do we give them APIs in GitHub? Or do we continue to be ticket driven? So.
Okay, so we discussed some of the challenges that we faced as a network team. Now I'll get into some specific solutions that we've been implementing over the last few years to help our automation journey. kind of as a day zero table stakes. If you're a network team, you should learn Python, Ansible. Once you get there, point being that instead of just running arbitrary Python jobs or cron tabs or ad hoc playbooks, you really want to try to condense your execution paths. So put guardrails on your engineers. In our case, we were able to leverage some existing tooling that our product engineering team had. For example, they already had a GitHub Enterprise account, right? So we're going to use that. They had Drone CI already integrated into GitHub, so we're going to leverage that. So we created some guardrails, meaning, all right, if you're going to run a Python job, let's put a wrapper around that where, network engineer might come up to me and say, I want to write a Python job that connects to the VPN server, pulls up some data. Great. Don't just create a Python script on some cron tab somewhere. Let's put it in a drone CI job, version control through GitHub, and then you could run it directly, or you could just hand it to the team that wants that data. They could run the drone job if it's a read-only type of job. Or if it's something that's scheduled, let's put it in a Lambda. Let's wrap it behind a Terraform construct. So now we have version control, you have visibility, and you see, okay, so if a year from now somebody wants to update that script, great, it's all version controlled, it's all GitHub, then you deploy it to that Lambda. So that's kind of the Python side of it when we run some of our tooling. And then on the Ansible side, so we do use Ansible because it's a great tool, we go with Ansible Tower. Again, centralized execution, access control, visibility. It gives us ability to repeat steps, and we can also manage our secrets. Let's move forward here. So by that same token of condensing our execution paths, we also want to condense our data paths, right? So if you think of all the hundreds of routers and switches and firewalls on the network as their own kind of autonomous databases, all holding some state of information, you want to try to put that all into a single relational database. NetBox is what we use. It's a great product. Now, I'm not going to call it, a source of truth. It's kind of source of truthiness where you can reference the jobs, the information that you need for future workloads. Use it as a launching point. So for us, we use it to launch some of our observability platforms. So if we need to dynamically populate a list of all devices that need to be in, let's say, Sumo Logic for logging, as log aggregator, we have that, right? Or if we're using a monitoring tool, again, we populate that from our source of truth, as well as automation operations, obviously, and more importantly, for configuration management, so all those vendor issues, that, those multiple vendors that we talked about, we can start smoothing out that hill of multiple vendors by trying to apply golden configuration and golden services across multiple vendors. A quick example of a golden config, you have a Ginger 2 template in GitHub. You can apply conditional logic, dynamic variables, pull those dynamic variables from NetBox config context, and then you can pull secrets from Vault, let's say, and add that all together. So now you got your data in one place, and if we step back a second and we think about the centralized execution, now you have that golden config. Now you have a place to push it out of, Ansible Tower in our case. And Ansible is great for us because now you could do a commit check, right? So you have an idea of you want your config to be this way. You run it through your network without making any changes. You do your check mode. You see what changes would happen. You're in compliance or you're not. And then an engineer can decide, all right, I'm going to push this out, revert somebody else's changes, or make changes that way. So you really want to do that to kind of smooth out your landscape, right? Again, with the many-to-one idea, you want NetBox to be your source of your drivers to all your tooling, right? So all those Python scripts we're talking about, those glue scripts, those jobs, you want to use dynamic tagging. In our case, we have dynamic tagging for our InfoSec team needs a list of IP addresses or servers that they got to scan. Okay, we give them an abstraction layer into NetBox. They can hit a Slack command. They can get the information, or we can give them an API. We're working on a ServiceNow integration as well. So we have ways for people to get the data themselves, or they can ask us, and at least we have it in a centralized place, not in somebody's Excel document somewhere. And again, another example might be the DNS team. Needs to know our egress IPs of all of our remote sites. Again, we could tag that in NetBox, provide a dynamically accurate list to other teams across the organization. So that's config management and operations, which is important, but just as important, I believe, is the idea of a digital twin. So that's nothing, so in development, the development world, that's nothing new, right? Having a staging or alpha or beta environment has always been the case. With infrastructure on-prem teams, at least I haven't experienced a really good way to have a fully staging environment. But more recently with Container Lab, the folks who spoke here before, it's been a real option, right? So now you can create infrastructure as code for your, in our case, not our whole network. We pick and choose pieces that we want to try to emulate, and then we can go from there. So a perfect example, a little while back, we built out a new Arista cluster in our data center for a storage project that required some 100 gig connections for our multimedia team. There was some supply chain issues, so we didn't get all the gear ahead of time. But what we did is we built a solution in Container Lab where we took the CEOS image, deployed that on CloudVision using Carl's, I think, he's here somewhere, Carl's playbooks that he has up on GitHub, put that up on CloudVision. So now we had a fully functional staging environment so that when the switches did come in, when the supply issues cleared up, all we have to do, we flipped a flag in our pipeline that said, okay, instead of deploying to the Container Lab images, now deploy to production. And you can also test that. So the important thing why this is important is you can test the behavior of your network, right? Your configuration might be accurate, but you don't know if the behavior of your network is accurate. But you can stick Linux hosts on each end of these, right? You can MLAG them together, put Alpine Linux on each end. Now you could do iPerf tests across, HTTP tests across. And you could test routing changes, and it's a really great tool for validating your network. By that same token, we've also created some pre-can labs for some junior engineers to just spin up and just start testing out. Maybe they've never worked with BGP before. Well, to eliminate some of that fear part we were talking about earlier as a challenge, well, this is a great way, right? So you create little self-service labs for yourself and spin them up and go for it. I have some examples. I know they're linked here, but just search GitHub. I open source some examples of how to do this stuff. Feel free. Now, the last solution I'm going to talk about, the idea of, it may be in a fully autonomous, self-service, self-healing network. You don't need to do this, but I think in a brownfield network, you have to do this, is you always have to go back and check your state. Because you don't know what's going to change. You don't know if some provider out in the middle of nowhere, maybe changed their IP on you, or some firewall fails over in a way that you don't expect, and there's different state on the network. So we have jobs that go out, check our state, feedback the source of truth with good data, so that the next time our jobs run on, iterate, they run correctly, right? So there is that constant syncing back. I don't know in a brownfield environment if you could ever have a fully trust the declarative left side of it without always doing that sync back check, at least in my experience. Just a quick example, in NetBox, so we have a job go out, update some or maybe an IP address on an interface. And we have other examples that do this. For example, let's say Fastly or GCP changes their public IP addresses, right? We'll have that and checks that and updates a firewall object. So all that type of checking and syncing, I believe, is important. Quick recap: platform engineering is great in the cloud, especially. It's harder to do on-prem. Those are some of the challenges we discussed, and some we discussed. That's, I think, it for me.
Can you talk a bit about how you interact with your app teams? When we were preparing for this, I found it very interesting, like how you guys collaborate, because I think it's pretty unique.
Specifically with the cloud teams, with
shared repos.
Oh yes, yeah. For the cloud routing part of it, yes, we do have Terraform jobs where if they need to make routing changes, we'll put in a PR, and it's a shared repo where we'll put in a PR against the transit gateway. It'll make a Terraform change on the centralized accounts that way, and then we could also see that as code as well.
Yeah. We don't really have audience participation in our presentation, but are a lot of people using shared repos between teams? I find that super interesting. Yes? Any feedback on how that works for the rest of the audience? I know we're going questions the opposite way here. I don't know if this is this acceptable? Because I think part of
it's both acceptable and encouraged.
I appreciate it. So, because when we get into platform engineering, I mean, buzzword, whatever, but the engage, it's really how we engage with our end users. I find that massively interesting. So like there's obviously we can all publish APIs and say, hey, come use it. But the idea that two teams that don't work together every day are making changes in a shared space, you know, in the open source community, I know it's a little bit different, but for production workloads, I find that interesting. So maybe a little insight back there.
Yeah, I think it's super useful. I mean, even if it's just getting them read access into your repos, and maybe, you know, it gets that trust going and collaboration going. It gets you visibility into like how I'm building the network or how I'm operating with the network. And then on the DevOps side, right, if you find a bug with some workflow and the application side, they're super happy you start contributing PRs into fixing some items. So that's huge. I also do it on the application side, right? So some of our devs, it can be very helpful. And they can deny the merge request if they want, or they can ask me more about it or do whatever else. But yeah.
Awesome.
Huge.
Yes, somebody mentioned GitHub was like a collaboration tool earlier. I mean, collaboration within your team is one thing, but when it's collaboration outside of your team, massively different.
And that actually did just trigger a memory for me. So we are actually in the middle of a project right now where we're changing some public IP space, and we can search the repos of what other teams are putting in their security groups, and we can make a PR against that and say, hey, we suggest you change this security group to what these new IP addresses will be. And we have that visibility because it's that shared platform. So.
And are they providing, I'm sorry, just real time here. Are we, are they providing you backlog, or are you guys just, like, are they also providing backlog for work for y'all? Because I'm sure there's stuff that requires your insight and expertise.
Maybe not so much in a programmatic way yet, because I don't think we're fully there yet. But yeah, I mean, here and there, yes, there will be requests that come in that we know we should work on, whether it's some routing. You know, if one team, perfect example, we had a pub tech team needed to route to a different account in Amazon, which the routing wasn't there because the transit gateway route wasn't there. Mm-hmm. So we talked, you know, over Slack, and then, you know, we collaborated through GitHub, see what the change would be, did a Terraform plan, figure out what that would be, and okay, this is the change, and let's do it. And let's do it in their dev account first. So there's collaboration that way among teams that usually never talk. Sometimes the only times I talk to my developers is like in a conference like this if they happen to be here, right?
Gotcha. Plus 5 points for the most Terraform references as well.
Sorry.
So I guess getting into like, what does it mean to build a product, and what is a product mindset? So it's really, you know, we typically think this is exactly right. Like we have a transit gateway, and guess what? That transit gateway is shared because, you know, for a lot of reasons. Maybe we have dedicated VPCs. Maybe we need to share those for within apps, or maybe they cross accounts and all these types of things, right? So we start thinking about what is a product, what's a feature? You know, is it connectivity? Is it security aspects? Is it availability in regions? Is it environments? Maybe in dev, you do whatever you want. Maybe in prod, I need to do PR, all these types of things. But then a lot of things I think we don't think about when we build products is really about non-functionals. So who can access it? You know, there's security that's both explicit, like I need to get from point A to point B, and then implicit, like we don't let people do that here. So there's a lot of non-functionals, you know, between you know, external systems to update, auditing, logging. There's all these things that I think we need to contemplate as we do products. You know, I've said it before, but you know, letting the person next to me run my script is okay. Letting somebody I don't know run my script, scary. So as we produce products, we're gonna have people consuming our network services without us sitting there and like approving it. So therefore, the guardrails and the feature sets that we need to think about from a product mindset perspective is obviously much larger, but I think the juice is worth the squeeze on that one. And then maybe a little bit about how to get started. So we've heard it today, you know, starting small, really thinking about the task automations that you have. I mean, I think, you know, this conference is unique in the fact that this is a very advanced cohort from the industry. But, you know, my Python was said, I don't know, a lot of times today, my Ansible, some of my Terraform, my GitHub pipelines, all those types of things, which is awesome. So let's start with what we got. We all have lots of stuff. You don't need to start over. It's really about how do we up-level what we have. And how do we start with something small? People say, I can't do this. I can't offer a product. And I usually say, can we just do a record ads? That sounds like not super crazy talk. So start with something that's meaningful, because you do have to do a complete vertical slice when you're going to offer a product. And then some of the aspirational stuff we talked about, I think most people would think Kaon's examples are pretty aggressive and advanced. But there's a lot of platform attributes. Sorry, it's hard to read from up here. Yeah, it really comes down to speaking to our customers, understanding what their consumption models are, how do they want to work with us. Excuse me. Maybe they want to share repo, maybe they want to make API calls, maybe they want to request tickets. But really taking on that product mindset, I think leads you towards platform engineering, separating application DevOps from kind of an SRE infrastructure mindset, and we can make lots of progress. And that's what we got, Mark. I think that's it.
Oh, we're good.
Oh, yeah.
Let's do a big round of applause. I think third talk of the day with dual speakers. I'm liking this format. We're going to do more of this. Any questions? That's convenient.
So on your feedback loop mechanism, a great talk, by the way, and the back and forth at the end of the day, I think kept us all awake and engaged, and I'm totally serious. So the mechanisms you described, would you say they're non-real time?
No, they're scheduled to go back, yeah.
So batch type processing.
Right.
Do you see value in taking more telemetry and other visibility and observability feedback, like from our friends at Kentic, to do more? Or are you already thinking of doing that? Talk about that a little bit.
Yeah, I think there's definitely value in having more real time and that lag, right? You don't want that sync lag. There's definitely value there. It's just about time to develop those solutions. We're kind of doing like a grassroots solution where we're building a lot of these jobs I've been talking about. So it's just like, okay, this is what we did for step 1. We've evolved it maybe to step 1.5. But yeah, I could definitely see that as a step 2 or 3 in the future. It's just for us, at least for our small team, it's just cycles. How many times can we do that?
All right, there we go, another one. Let's keep it the front row. I'm getting tired. Let's keep it all down here.
So for that feedback loop, what are you guys using for that job? It looked like Ansible. Was that what you were using?
Sometimes Ansible or Python that just talks right back to NetBox. Okay. Or if it's checking, checking like outside services, Python and Ansible for the most part.
Okay.
All right, nice and quick. Anybody else? No? Going. Gone. Huge round of applause, please, for our last speakers of the day.